Okay, good afternoon, everyone. My name is Chris Branch. I'm a systems engineer working for Cloudflare, which is an internet security and performance company. I'm substituting for John Graham Cumming, who couldn't be here today. He's the CTO of Cloudflare and my direct boss. I normally focus on DDoS mitigation. So as far as I see, web attacks are a way to prevent the botnet getting bigger. But we felt it would be interesting to show you some of the things that people actually do, given an arbitrary code execution vulnerability. What do people actually do with that power? Is it just shellcode or is it something more? So Cloudflare is in the unique position of being able to see all these attacks as it stops them. Cloudflare is one of the largest DNS server and caching reverse proxy deployments worldwide. An important part of our security is the WAF, the Web Application Firewall. It blocks attacks that match a particular attack pattern and prevent them from reaching the origin server and preventing it from compromise. We see a lot of attacks and attack attempts because we block them. We also see a lot of people trying old attacks as well as the newest ones that we see CVEs for. So today we're going to talk about two particularly high-profile attacks, one from 2 years ago, which is Shell Shock, and one from earlier this year, which is Image Tragic. They're both arbitrary code execution vulnerabilities. Both come from trusting user input when they shouldn't do. But the reason they're high profile is because they're extremely easy to exploit, and a lot of software is vulnerable from it. So Shell Shock. It's so named because it affects the bash born again shell. It's actually a very old bug, but the implications were only publicly disclosed about 2 years ago. It's caused by a fairly obscure feature in Bash, which lets you export functions as environment variables so they can be executed by a child process. This command line here will tell you if you're vulnerable to shell shock. If you're vulnerable, it will execute the echo vulnerable and print vulnerable before it executes the actual command you intended to execute. Normally, you export an existing function definition in Bash by using the export commands. You say export-f and then the name of an existing function. But environment variables are ultimately just strings. So nothing stops you from crafting a function definition in the exact same way that Bash does. When Bash detects an environment variable that looks like a function definition, such as the one at the top, it will execute the environment variable as a command line. And when Bash does it, that's fine, because the only thing in that environment variable is a function definition, nothing after it, so no side effects. But as a human using Bash, we can do more than that. We can append arbitrary commands to it, as in the second case. And then when you execute Bash, Bash will look for environment variables that look like function definitions and execute it as a command line. And then we're owned. It's not good and caused by trusting user input when it probably shouldn't have done. Now, how does this affect the web? The examples before, you already had shell access. You could execute the command yourself if you wanted. But imagine if the environment was passed to a more privileged process, like you would run sudo. Or if you got a remote server to execute the function through an environment variable. Unfortunately for us, this is exactly what the CGI specification does. It passes HTTP request headers as environment variables, things like user agent, referrer, content type. So as soon as you run a shell from a CGI script that's inherent to parent environments, you are vulnerable to shell shock. Vulnerabilities include, but are not limited to, remotely ejecting the DVD on a web server. This was an actual request that Cloudflare saw and blocked, but you can imagine much more evil exploits can happen. So when the CV was released, we rolled out a referral for our paying customers. So they were immediately protected from shell shock even if they hadn't patched. Once we established that the rule was good, we extended it to our free customers to better protect the internet. At the same time, we also measured the amount of attack attempts we saw trying to exploit the shell shock vulnerability. As soon as we turned it on, we saw 10 to 15 attacks per second, with occasional bursts of activity as a specific website was targeted. Even today, 2 years later, we typically see around 5 attacks a day. So, the subjects. What do we actually see? What do people do with arbitrary code execution? Well, Apart from ejecting DVD drives and other physical frames, lots of things like data exfiltration. So getting access as nobody or www data is one thing, but you want to try and find the root user and exploit the system that way. The hope here in the first command is that the standard out will contain the password file somewhere in the HTTP response. Not everyone was confident about that working, so they opted to email themselves data instead. Many attacks that we see are simple reconnaissance. An attacker will make a victim server contact a server under their control with a string identifying the website. So this first attack uses ping, encodes a payload in the ICMP packet. The second uses a unique HTTP request. In either case, the attacker will look through their logs and correlate IP addresses making these requests with the websites that were attacked. This is a particular problem for a service like Cloudflare. The way that our reverse caching proxy works is we send a request to us, which obscures the origin IP address. If the origin IP address is revealed, then our DDoS protection could be circumvented by attacking the origin directly. So we can only hope that these are more innocuous white hat attempts to identify sites. And depending on the setup of the web server, this particular example where we sleep for a minute could be a denial of service. Imagine, if you will, you have an old Apache version with a fixed worker pool of processes. If you block the request by sleeping for a minute, then after a few requests, you can completely exhaust the pool of worker processes and deny service to anyone else. It could also be just an out-of-band way of determining if the server is vulnerable or not by seeing if the request runs slower than normal. Of course, why limit yourself to one command? Shellcode is what we're all expecting. But there's more than one way to skin a cat. Most people would safely assume that Perl is going to be installed on every web server. Probably right, especially if they're attacking CGI. A more interesting attack we saw was someone trying to masquerade as the ClamAV updater service. The irony here for sysadmins seeing this in their list of processes is they might not choose to close it because they want to make sure they're protected by antivirus when they're actually just running a malware. So the path patterns that we commonly saw attacked were the root, which makes sense. But we also see some more specific patterns. You'll actually see if you search for some of these, there's shell shock malware, which is packaged and actually attacks these paths as well, which is probably what the common attacks now. But these paths match pretty closely to the Barracuda firewall appliance and cPanel installations. The danger that we have 2 years on from the initial vulnerability, when hopefully everyone is patched, is hardware appliances might not be patched. If you plug in an appliance that was made 2 years ago and you haven't updated it yet, then there's a real possibility that it gets compromised by shell shock. And that's assuming you even have a way to update it. So let's move on to a more recent vulnerability, Image Tragic. The authors felt that your bug wouldn't be taken seriously unless it had a cool name and a logo. They're probably right. When it was revealed, the similarities to shell shock were widespread. The reason it's similar is the ubiquity of the compromised software. Many web applications use ImageMagick for image processing. It has bindings to popular languages and frameworks. And because it is another example of an arbitrary code execution. It may not be as simple as sending a specially crafted HTTP header. You have to find an HTML form and upload it and hope that the application will interpret it as an image. But that's still not too difficult to achieve as long as you've got a payload. So a common way that you might exploit a website is by looking at open source software that actually uses ImageMagick. And there's a large class of software that does. Forums, blogs, CMSs, and obviously photo uploading sites. So what makes this easy for the attacker is they can craft an exploit for a particular software package, and once they've done that, then hundreds and thousands of websites are vulnerable. So how does it actually happen? The problem is introduced by ImageMagick's magic. It processes files using external commands. It defines the commands that are used for different codecs. in an external file called delegates.xml. It seems fine. Unfortunately, because these are actual command strings, you have to be quite careful in much the same way that you have to be careful when constructing SQL queries. In this particular HTTPS codec, we weren't careful. The %m parameter was not adequately quoted, double quotes were not escaped. So this allows you to break out. Imagine you start off with a legit looking URL and then append your own custom code. Here's an example of a malicious SVG. Starts off innocuously, but here in red we have the image tag which references an external resource. So not quite. At the end, we break out of the quoting and we list the current directory contents. If you copy that and save it to a file, try to run it through ImageMagick, you'll see that it will list the current directory contents as well as convert your file. Many of the problems were not SVG. They were actually caused by MVG, which are magic vector graphics. Now, this is a language designed by the ImageMagick implementers used to generate images in a more convenient way on the command line or in the file. Unfortunately, they have a lot of capabilities which perhaps are not suitable for user inputs. So one more obvious example is it can download arbitrary files off the internet. Not great. It can also cause server-side request forgeries. It also has a few custom schemes. So here we have one for having a temporary file. What do you do after a temporary file? You delete it. Not good. You can also use it to read files. So if you have a text file, you want to output it as your text, it seems convenient, unless that text file is a list of all your usernames. We designed a way to block this in our WAF. Here is the regex expression, and it's easier to digest state machine form. Essentially, what we try to do is block both SVG and MVG. So the first two lines will block HTTPS requests using SVG or MVG, and the second two prevent the data exfiltration and deletion vulnerabilities. Surprisingly, here's the most popular payload we saw using MVG and not SVG. This is similar to the reconnaissance attacks used in the shell shock vulnerability. The image did exist, so if you actually try to run this as a MVG, I convert it as MVG, it would look like the file that was referenced, except it would also make a callback to the attacker's domain. The second favorite was actually SVG. Because it's possible for you to disable codecs which you don't use, for example, MVG, there's probably more success from using SVG, which is less likely to be rejected by the application layer above ImageMagick. Here's another more interesting one, which merely downloads a file but doesn't do anything further with it. We suspect it's part of a larger attack, or perhaps as a way to not draw attention to the attack vector that the attacker was using. And this one, of course, downloads a shell, and this one is used in Python. The source code was actually available, and we're going to have a look at it right now. So here we see we have a Vim user, always a fan of mine. And if any nosy sysadmin decides to inspect what this code is doing, they see it in a process list, they wonder what's happened, they can feel relaxed because it was written by the Google security team. And we all know they can't be evil. So you can feel happy about that. And surprisingly, it's quite well written. It has a illusion if you don't play the arguments, even though the only person using it should possibly know what it does. But the code itself is pretty simple. It's nothing particularly spectacular. It even has error handling. I've elided some of the environment setup, and in particular where we create a sudo tty. But it's pretty straightforward. But why stop there? Why not have some shellcode code to golf? This one is packed all into a single line. We actually generate the file and then execute it as Python. Or how about this one, where we actually, we don't even bother trying to have an image. We just create a new bash session and redirect it to the TCP. This is a bit more robust because now we're not tied to the child parent process. And nothing would be complete without using the duct tape of the internet NC. Here we actually do have a good attempt to hide what we're doing using a legit image, and the command line is possibly the shortest, so definitely my favorite attack method. So in conclusion, people do a lot of interesting things, but the main takeaway is that if you don't patch, you probably will get hacked. When an exploit is easy to create a shell-shocking image tragic art, it's a matter of hours before your site gets scanned. Lots of people were trying lots of different things. If it was a difficult exploit, people would just use the proof of concept or the first one that's released and not go any further. So that's always a scary prospect. If you don't patch, if you're lucky, the worst thing that will happen is your CD drive will just pop out one day and you'll not know why. If you're not lucky, or even worse, you happen to be in the wrong time zone and be asleep when the vulnerability is released, you might wake up to a nasty surprise. So even if you think you properly sanitize your inputs, third-party dependencies might not. The shell-shock vulnerability and image magic vulnerability were not caused by bad application code. It was caused by bad library codes or just something so basic in a system that you don't think about it. One way to solve it is to obviously patch your systems, but if you don't, or if you can't, or if you have an old system or hardware appliance that can't be patched, then just try to block it other ways using the WAF or similar. Does anyone have any questions? Yes. Do we have a microphone? Let's pass around. I guess not. Well, thank you for listening.